All right, so after now, we discussed the case of a continuous random variable. And right now, how about the discrete random variable? I think follow the original image, case by case. But right now, we talk about Poisson. So sum of two independent Poisson. And what is the distribution for Z? You see, case by case. And case by this, by using partition or using union. All right, that says indicate all possible cases and put them together. We should have the union. And union, then partition, that you have the summation. Because they are independent and they are disjoint. At least they are disjoint. If they are disjoint, you can follow the current way to have the expression. You see, this is the proper partition. With the proper partition, you can have the manipulation. Finally, you reach this one. I think you guys, again, you should understand. I do not go through all the details, but at least that you guys know the key points. And if you can understand the key points, then you can reach your results. Perhaps you still need to have more time to check after classes. I think if yes, you just follow this way. And here, if you understand understand and get the key points, then finally you can reach the results. Once you reach the result, I just want to draw your attention to examine the form. The form here, what is the name for the form of the PMF? Poisson again. And with the parameter of the sum of the individual parameter. So here, if we have a summary, Poisson, independent Poisson. Sum of the independent Poisson result in Poisson. So Poisson, and Poisson. Here it's Poisson. And in fact, we may have the splitting Poisson, but with a probability maybe Q and 1 minus Q. Then Poisson again with a rate lambda, and here you should have a lambda Q and lambda 1 minus Q. And that's it. However, for this one, you guys need to check it further. At this moment, I just let you know the results. And in fact, if you want to know, you need to check it. All right, so for discrete random variable, still the same, case by case. And you can have the derivation. And for this, we may have the special conclusion. Sum of independent Poisson results in Poisson again. And how about parameter? Parameter is sum of all the individual Poisson parameters. And that's it. As for the splitting, splitting, similar results, but need to follow the assigned probability. Somehow like assign probability to get the individual rate after splitting. Okay, so still have Poisson, but you need to readjust the rate. Readjust the rate by multiplying the corresponding probability. And so that you will have the net rate to the specific branch. And that's all. So this is the second supplement. Is it okay? I think you still need to have time to check it. So maybe some of you feel not okay, or maybe some of you okay. But it's normal because I do not go through all the details. I should confess. So the best solution is take time to check O, and so that you will understand O, and that's it. All right, so this is the second one. And let me go through the next one. For this one, in fact, it's really symmetric. 2 2 to 2, right? So symmetric one, xy to z and w. Sometimes we may have the 2 to have the decision rather than 1 to have the decision. So at this moment, we have 2 to have 2 variable for you to have the decision. Once we have this, then we have the question. How about join? How about marginal z and marginal w? I mean marginal PDF for z and w individually. So these are the goals of this supplement. Likewise, we may have the region. So the same. We may have CDF first, then PDF. Okay. So these are the possible examples. I think you just follow the description. And I just let you know these are approaches, but it is approach 1. Well, approach 1, for the previous supplement, I don't have approach 2. But how about the current solution? We may have approach 2. By deriving the specific formula. So here, this is the formula, approach 2. Formula. And the general formula. Well, the same. We need to follow the tedious procedure here. Right? The tedious procedure here, but something like we may have these ZW, ZW, DZ, and DW. But the summation of X and Y, X and Y, and DXDY. But we need to have the absolute value for sure. Well, normally something like that, but we just follow the current discussion, and then you will realize we may have some extra technique. You see, we may have a lot here. Transformation, right? Because maybe not really okay, but I just try to draw your attention to this Jacobian. Because we have the proper transformation, so we need to have a Jacobian. Okay, so first of all, I draw your attention to Jacobian. Maybe talking about Jacobian is far from your current memory, because maybe talking about Jacobian, it should be 4 years ago, right? Because Jacobian perhaps appears in your mind during the period of freshman. Am I right? All right, I think far from your memory, but we still need to use it. So that's why I need to emphasize Jacobian. Well, Jacobian, how to apply Jacobian? The same, you see. I have the previous expression, but this one, Jacobian. So let me have this. I re-emphasize, maybe not differentiation. Perhaps right now we need to have the partial differentiation. So I have x and y. And the partial differentiation with respect to z and w. Oh, sorry, z. However, we have the absolute value. And for Jacobian, how to have a Jacobian? If we have this one is a determinant first. Actually, no need to have I. It's x and y. So determinant. We should have the determinant. After the operation of a determinant, don't forget the absolute value. This one determinant. Right? Okay, so if we have the way to memorize d, z, dw, and dx, dy, the dx, dy over dz, dw should be properly changed to Jacobian. Okay, and that's it. So if we have the way to have the formula with the concept of Jacobian, then we can apply the results. Okay, so next one, the same. We should apply the result to Jacobian. And for this, I think you guys can check it. For this one, maybe I skip it. Even this is the initial one, but let me skip it. You guys can check it. I show you this one. All right, so I show you this one. And right now, xy map it to u and v. All right, and right now we have this original one, exponential. So exponential, then you have the join. Join PDF through multiplication. Then we can have the join one. But how to apply the previous formula? By caring about the Jacobian. You see, Jacobian, then we need to have this. And Jacobian, then we have this. Jacobian using determinant. This one v. Y and uv. Sorry, this one should be partial. But actually, no need to perform partial. Y and dw. Something like this. Let me recheck. Partial, O partial. Yeah, O partial, sorry. D, so I have the mixed notation. O partial, all right. If O partial, I just follow this J. J, what is J here? J exactly equal to U, so a half. V, a half. U, a half. V, minus a half. So finally, you should have minus a quarter, right? Am I right? Let me check. Sorry, not a quarter, a half. Minus a half. Sorry, not minus a half. Yeah, minus a half. The j here not the same as mine. Okay. So that's why I use this j by using a notation. Or u or v. And this one follow the definition. Right? And that's why we have the result, a half, minus a half. Finally, we have minus a half. If I have the minus a half, that's really easy. For these, no need to have a summation because we have a one-to-one mapping. So you just follow the results here. UV equal to summation, but at this moment, no need to have a summation. And then multiply the Jacobian, but these. So actually, a half here, you see, we have a half. And as for the remaining, this one map it to U and V. How to rearrange to U and V? You see, this one constant, okay, and this one sum. Sum it's U, so it's U. So finally, it's U here. Okay, so if you follow my way, you just multiply my J. Okay, it is not the formula of the formula here, right? No. Okay, here it says use reciprocal of the del J, not my J. My J is this one. Okay, the reciprocal of the J on the slides here. Then I want to emphasize to make it easier to memorize, so I do not follow the formula. It doesn't mean I do not have the correct formula. I just correct some of the notation and make my notation easier to memorize. If you understand me, I think up to now, you will understand we can reach the formula. Am I right? So up to now, any question for this? Well, if no, we need to check this one further. If you have the formula here, think about this. X and Y, right? For X and Y, the range here. So X greater than Y greater than 0. So you have these. And put them together. So that's why we have these. As for the remaining, I think you understand, of course, greater than 0, lower than infinity. I think you can use a way to know the range. To know the range here, right? Once you know the range, first of all, if I want to have the marginal U, so in terms of V, so V follow the form V. So V minus U and minus U. So that's why this. Through integration with respect to V. All right, so I think if you follow this one, then you guys can check. Is it okay to have the remaining results? If you follow U, look at this. positive, positive. Okay, and U here, positive, right? So that's why positive. But for V entire, right? For V, you need to perform integration with respect to U. U this range with the absolute value of V to infinity. If you know this, I think for remaining, you will understand, right? Okay, the same. For saving time, I just let you know the key points. As for the manipulation, I think you guys need to check. Can you achieve it? And of course, perhaps you need to take time to recheck. If you totally understand the key points, I think up to now you understand me by applying the formula. Am I right? And that's it. So this is the specific example. This one I have the special attention. So even I don't have the details for all, but you need to check in detail again after classes. All right, that's it. This is the example. Example 9.3. Any question about this? Well, I assume no. So let me continue. And up to now, if you know the results for 2 to 2, using CDF first, then PDF or formula, right? But why we need to have these auxiliary variables? Remember, supplement 2, we only have 2 to 1. Is it okay we define another 2 to 1? So that we have a 2 to 2. For example, you can define. Right now we have a Z. You can define W equal to X or W equal to Y. And try to find ZW. Once you find ZW, try to find Z. If so, this is a concept of auxiliary variable. For example, in the past, you may have the results for Z equal to X plus Y. And for that case, you need to use case by case to have the derivation, right? And right now, if we have Z equal to X plus Y, and if we have the extra variable W serving as the auxiliary variable, then we can use the current formula to have the solution. You see how to do this one. If you can check Jacobian, it's 1. And it's 1, so it's really easy. ZW equal to this because of a 1-to-1 mapping. And Z equal to X plus Y, and W equal to, wait a moment. Y. Okay, so here it's Y. And this one minus W. So this one. If we have this, how to do? Perform integration with respect to W. Right? W, right? And look at this. Can you have this one the same as the previous one? Yes. So if you don't like the previous derivation for 2-to-1 mapping, you can use the current one 2-to-2, but you need to have the help of auxiliary variable. If you have the further definition of the auxiliary variable, and then you can use the formula for 2-to-2 mapping. You understand me? All right, that's all. So for the remaining, I think you can follow the examples. And likewise for the special case, discrete one, I think the same. You just follow the discussion. This time, I think you understand. So it is a case-by-case approach. So you just go through that. Well, that's it. This is supplement 3. Maybe I use another speed to let you know the content quickly. I think you can understand me, but you need to take time to go through all the details for the current content. Well, the same up to now. Any question from you? Up to now, let me have the quick summary. Supplement 1, we have CDF to PDF and also the formula. Supplement 2, we have CDF first and the PDF without the without the general formula. 2 to 1, but third supplement, we have 2 to 2. We have the CDF first and then PDF. And also we have the general formula, but the general formula needs to apply the concept of Jacobian, and that's it. And all of these apply to the continuous random variable, not the discrete random variable. For the discrete random variable, you need to have the case-by-case solution, and that's all. So these are the current methodology for our 3 supplements. Is it okay? If it is okay, then let me check the next one. You can find supplement from Moodle. I already have the. Oh, sorry. Maybe it is I random some of the result from the previous course, but the course it is not the name here. But I emphasize this. Useful results. Here, 1, it says discrete 1. 2, it says normal. If we have the transformation, then we have normal again. The same if we have normal. Then how about square? You see, previously you have the mapping. So I think you will understand how to have the derivation, but we don't have the direct linkage. Normal map to gamma density. And also, how about gamma? And sum of gamma, it's gamma again. And also normal, and sum of normal, and it's normal again. And this one, it is a definition, chi-square. Chi-square is a special case of a gamma. And also, this is a definition. Chi-square with a degree of freedom k sub 1, k sub 2. How about the ratio? And this one, it is a definition for F distribution. And another one, if normal, standard normal, chi-square. Ratio of these, then it is called T distribution. Well, T distribution for confidence interval? Yes, that is a T distribution for confidence interval. And right now you can follow the relation of these to know how to define T distribution. And finally, look at this. If we have the statistic, we will prove it's chi-square with a degree of freedom n-1. What that means, if we have this, know that chi-square, why chi-square? Because you can follow the previous results. And also the result using Jacobian. Maybe some of the derivation here need to be updated. Slight modification is necessary. But I think you can follow the concept here to know the proof. Once you know the proof, just follow the steps here. You can have this. Well, look at this. Sample over sample mean, not over, minus sample mean, and rest power to 2, and over the common variance, sigma square. Then we have W2. And this one follows chi-square distribution. Okay, so this is a supplement. And I also that you have this. The proof. I think you just follow the proof. You just follow the proof. For example, here. First one. And then you have some of the preparation. Some of the preparation by using a generating function. Okay, maybe you are not so sure, but somewhat like the transform. Okay, if you can accept this, you can follow this to prove it. All right, so this is a first one. And for the second one, normal through the linear function, it's normal again. I think this one you can use supplement 1 to know why, right? So this is supplement 1. I think you can understand this. And this one, the same, supplement 1. Sorry, 1. Because we have y equal to square. However, if we have the square, using the current discussion, we also that you know how to define gamma. Sorry. Gamma function and gamma PDF. All right, so I think you can follow this to know gamma probability density function. This one. Oh, sorry. Oh. This one. All right, so I think through the PDF, through the supplement 1, you can know this. And likewise, this one, supplement 2, you can check it. So by checking this, and this one, supplement 2, right? And I just have the possible linkage. And this one, I think, by definition, right? So you just treat, you have the definition. But we have the further discussion. And this one by definition. But we have the discussion as well. And this one by definition. Right? And this one, I proved it already, right? Okay, so this is supplement 4. We have the list of useful results. And this is supplement 5. I provide you the way to prove. And in fact, we have one of the remaining results, but I don't check it. Next week, perhaps we can check it quickly. Which one? This one. This one. Actually, the useful results allow you to prove this. Why? In fact, next week I can use the supplement to let you know why. Right now, I let you have supplement 1 to supplement 5. You can apply the supplement from 1 to 5 to know this. At this moment, maybe I do not let you have the solution, but I can let you have it. Perhaps I can find it and use it to serve as supplement 7. But before that one, I want to let you know this. Let you know this. Okay, so how to have the results? I show you the details using this one. You see? Here we have this result, right? And I show you the results here. Sorry, maybe I do not show that one. I just show you the unbiased results. So this one, it is the estimation. It is the expected value of a sample variance. So this one, sorry, I get to wait a moment. This one, I try to prove this. Right? So supplement 6, I provide you this one. So how to prove it? So you check it. All right. So if we have that one, then we can know this is an unbiased estimate. That you know this really easy, right? That you know it takes time, so I do not have the right result. But this one, it is okay, but it takes time. Takes a tedious procedure to prove it. So I provide the results in supplement 4 and supplement 6. So I think you can check it. Well, I think you guys may have a question. Why I need to provide these supplements? Because next week we will reach chapter 6. I jump chapter 5 because chapter 5 perhaps we can treat it as an optional chapter. So that's why I want to skip. I jump to chapter 6 directly. And if we go to chapter 6, then you will understand we need to rely on results of chapter 4 and the supplement of chapter 4. That's why even the time is really tight, I still want to ask you guys to go through the supplement. and hopefully I think you can benefit from those supplements. Understand me? I think you can check the results once we reach chapter 6, and that's it. All right, so that's all. Perhaps next time I will show you why T distribution value for the confidence interval if we have the normal random variables. And maybe I will have the supplement directly for you, or maybe I can have the handwriting directly for you, and then you will understand why. All right, that's all. This is a discussion for today. And any question? If not, I think I strongly recommend you all to review the results and also try to have the deeper reading for all the supplements. And that's it. If no question, and then see you next week. Bye-bye.